So as you know, I'm Wayne, and I've asked you to come so that I can explain to you about my ideas for making self-powering generators. A bunch of years ago I had some interesting ideas, and ever since then I've been working them over mostly on my own. So what I'm going to do is I'm going to start from present time where we are now and spend most of the time explaining about my differential generator, which I've spent most time on. There are things that are worthy of some testing and further investigation because I'm not a scientist, and so all of the stuff that I've come up with is based on logic and basic schoolboy science.
Okay.
You know what I mean?
Yeah.
Which would be good if someone managed to be able to test out some of them. I do know that some of these concepts actually do work from work that other people have done.
Okay.
And I'll explain as we go along. And in all, I've got 9 concepts. Differential generator, the push pulse generator, which is a basic concept, the shuttle bounce generator, the centrifugal generator, friction ball generator, antenna generator, hollow mag generator, which is more of a type of magnet than a generator, and the spinning torus generator, which was actually an adaptation of my very first, which I never really developed fully because from there it just went in leaps and bounds and I got new ideas and it kind of got lost way back then. So more recently I've resurrected the basic idea and chucked it down on a piece of paper.
Okay.
And then the sequencing mag generator, which is where I spent most of my time in the early days, but I'll try to keep it brief. That's why I've left it till last, is because it's right where I started from.
Okay.
And it's also where I spent most of my time. And it's a very interesting and revealing story, that last bit.
Okay.
First of all, I just want to say about why I'm doing this. And that's basically because I've got a bunch of potentially very useful ideas and I don't know what to do with them other than just splurge them out to anyone who'll listen to them now. I've reached the stage where I could spend ages and ages till the end of days investigating this and investigating that, but without proper resources it's nothing meaningful I could do with it. I've got my ideas, I'm just going to splurge them out now and have done with it. So even though it's a potentially very useful idea, it's just a tool that could be used for many purposes. The overall idea for me right from day one was to come up with a small device that you could stick in a house, in a building, or in a car, or a hospital, anywhere, that can produce enough power to run itself and the building, for example. It works out far better that way than if you try and build these giant generators to provide a giant grid. It's very inefficient and very, very difficult. And these types of ideas won't work well at that scale. You know, it's just the physics, it's just the way it is. Some of them may do, but you run into all kinds of problems, I think. And besides, I believe that some of these devices will be able to produce a lot, you know, of electricity, even though they're pretty small devices physically. The other thing about this lot is you can't patent this type of technology because they break fundamental laws of physics, and any invention that breaks the law of physics can't be patented.
Right.
This has also been a big barrier to a lot of people doing this kind of work, because how are you supposed to claim ownership of something and make a pile of money from it, basically, if you can't patent it? So from that perspective, big corporations generally haven't been interested.
Right.
Because all you do is you don't try and patent the idea, you just splurge all the ideas out and let competition take its course. So what if there's 10 people making different models of machines? It's right that way anyway, because it'll keep the price down.
Yeah.
Some of these types of technologies have been successfully done before. Dr. Robert Adams in the 70s and Professor Searle also in the 70s, using a completely different idea, but also both of them using electromagnetics.
Right.
And both successfully produced working machines that generated loads of electricity and self-powered.
Right.
No problem. Technically, they were also perpetual motion machines because they never stop until something breaks.
Right.
That's just the nature of the types of machines, but they
understand.
aren't supposed to be put forward as a perpetual motion machine, because that's not the idea. The idea is just to make electricity, which is what we need. Otherwise all of this would be a waste of time. So it's my responsibility to share good ideas.
Oh yeah.
Here you can see I've used a few basics in my work. Simplicity, a lot of my ideas use magnetism, I use symmetry and basic shapes, the shapes of nature, and very specific materials for very specific purposes. You need these physical properties and these physical properties. I'll explain those along the way, because when I explain my main design, which I'll do first, I'll explain what all the parts are made of and why. It's very simple though.
Okay.
It's not like I'm going to teach you how to build a rocket.
Yeah.
This thing doesn't contain any electronics as such.
Okay.
It's all very, very simple. Schoolboy science. Right, so let's dive in there. First one is called a differential generator. And the reason why it's called a differential generator is because the core of it is split into two halves, separated by a very simple differential gear. So that the top half goes one way and the bottom half goes the other way, with differential gear wheels keeping it all in sync. I'll explain why I've done that as we go along. This is the whole machine, and what you're looking at is a result of a 3D design application called a Libre design. What I've done is I still have a bunch of questions that I don't know the answer to. What would work better than what, out of several basic ideas on how to do something. So what I did was I designed a prototype that can answer those questions, because it's very adjustable in a lot of different ways. You can adjust positionings and settings and stuff like that. Very basic stuff, but very functional, so that you can figure out what kind of arrangements work best and what kind of gap distances you need, etc., etc., inside there. And then once as you figure all of that lot out, then you can design a much simpler production model, which is dirt cheap to manufacture.
Right.
Okay, so this is the outside of the machine, what it would look like, and most of it is made of aluminium. This at the bottom here is a mounting stand, and it's got bolts that you can like bolt it down to a desk. It is a prototype. I've built in some safety stuff in as well. At the top here you can see it's got brakes. It's emergency brakes for something that spins around fast. Very simple bicycle style emergency brakes. It's got vent holes, but most of the vent holes are at the top and the bottom, because there's a fan on the top and a fan on the bottom as well that are mounted directly onto the axles that spin around.
Right.
So it's a cooling mechanism.
Okay.
It cools itself.
Yeah.
It does have a bit of an overhead because it's causing a bit more drag, but it doesn't really matter, you know. Not to this machine anyway.